Comparing the universe to an ocean isn't entirely accurate due to their incommensurable sizes, but it's the only analogy readily available to the human mind to grasp its vastness. In the cold, silent cosmic ocean, countless celestial bodies reside. Stars shining like monstrous lamps, planets of varying sizes, and swirling asteroid belts. Let's delve into a topic that ignites the imagination. Hypergiant stars. These colossal stars exist. Wait for sunset and look at the sky. Depending on cloud cover, the immensity of the universe will be revealed to you. Countless tiny, twinkling lights, which are stars. Explaining this to a child requires engaging educational resources. Many channels provide engaging educational content for children, including animated videos, audio stories, and educational apps. These resources are invaluable in sparking a child's curiosity about the cosmos. Despite our tendency to use superlatives like infinite and boundless, everything has limits, even hypergiant stars. Their mass and size approach critical limits. Their lifespans, from a cosmic perspective, are incredibly short, a few thousand, or at most a couple of million years. In comparison, a main sequence star like our Sun lives for about 10 billion years. Any hypergiant is several times more massive than even the largest known stars, exceeding even supergiants like Rigel or Betelgeuse. Their mass can range from 100 to 250 solar masses. Regarding size, the largest known hypergiant star is over 1,700 times the radius of our Sun. Their luminosity is equally impressive, reaching up to 500,000 times that of the Sun, and their surface temperature can reach 35,000 Kelvin. It's worth noting that such stars are quite rare. The Milky Way Galaxy likely contains no more than a dozen. These shining behemoths exist in a precarious equilibrium, constantly battling internal pressures from their scorching cores and the crushing force of their own gravity. Their demise, however, is spectacular. A stunning supernova explosion, transforming them into entirely different cosmic entities, often black holes. Scuti deserves special mention. It's one of the largest known stars, although its leadership is primarily in size, not necessarily luminosity or mass. R136a1 holds the record for luminosity and mass. Scuti is a colossal star located 9,500 light-years away. It's 340,000 times brighter than the Sun, and its radius, considering its pulsations, is about 2,000 times that of the Sun. To comprehend its scale, consider this. Traveling at the speed of light, it would take 8 hours to circumnavigate it. At the speed of the International Space Station, it would take 5 years. To visualize its size, imagine Earth as a grain of buckwheat and the Sun as a ripe watermelon. If Scuti were placed within our solar system, it would engulf all the planets, including Saturn. While studying Scuti, scientists discovered something interesting. Despite its enormous size, its mass is only 7 times greater than the Sun's, indicating extremely low density, 1,000,000 times less dense than air. Even our Sun is 1.5 times denser than water, let alone the superdense matter of neutron stars. Simply put, its density is slightly higher than a perfect vacuum. It's believed to be in its final stages, though it's possible we're only observing echoes of its existence, while a titanic black hole might already be warping space-time where the hypergiant once was. Another leading contender, R136a1, located in the Large Magellanic Cloud, a neighboring galaxy, is 163,000 light-years away. It's almost 9 million times brighter than the Sun. If planets orbited R136a1, the habitable zone would be 3,000 astronomical units from it. However, life on such planets would be impossible due to the intense ultraviolet radiation. If a star like R136a1 were 10 parsecs away, it would still appear menacingly large in our sky, about half the size of the Moon. If it replaced our Sun, its apparent size in our sky would be 100,000 times larger. To illustrate the potential catastrophe, consider that if the Sun increased its luminosity by just 10%, life would only survive at the Earth's poles. A 40% increase would transform Earth into a Venus-like planet. R136a1 contains 256 solar masses and is 22,000 times larger than our Sun. However, its immense radiation and mass make it extremely unstable. The star is literally tearing itself apart, resulting in periodic eruptions. Its eventual death will be truly epic, surpassing any previous supernovae. The explosion would be visible from Earth, despite the immense distance. Thankfully, it's far enough away. Otherwise, our planet would face a risk similar to the Ordovician-Silurian extinction event, likely caused by a supernova explosion 6,000 light-years away. What we see as twinkling specks are actually gigantic objects living by their own laws. Their numbers, sizes, and current existence remain a subject of ongoing scientific inquiry, often relying on indirect measurements and evidence.